Alright, greetings, welcome back. Let's finish up these slides as best we can. This is going to be a one lecture week because of Thanksgiving. I'm pretending that this is a Tuesday-Thursday class, and so we have Thursday off. So, just one lecture this week. We were talking about Java last time, and I forgot to add this little link to that one website that I gave you for C++ back in the day. There's also one for Java, so a little quick tutorial if you're interested in learning more about it. Please go there. So we learned about a few pieces of Java, and we got about to here. And now I want to give you a full, like a bigger example, and I have managed to get Vim to be nice with Java a little bit. So I'll use Vim now. Let's make a counter class. So again, we get to do all the same stuff. It'll have like a constructor, it'll have an inc method, it'll have a reset method, things like that. But it'll all look slightly different. Okay, let's talk about what needs to get done. All right, so let's say Vim, and I've already actually made this a little starting point for us. So Vim counter.java. So here we are. I've said public class counter, and that's about it. The one member variable for our class, it's going to be private, and it's an int. So remember that public and private have to go next to everything. Okay? Which is fun. You just got to remember that. It's a public class, everybody can use it. This is a private member variable of any object of that class. All right? So now, let's make a constructor. And so we'll say public counter. It'd be nice to give it a starting value, things like int starting value, be like equals 0 and do our stuff. But this does not work in Java. As I say up here in my comment, Java does not have these default parameters. So you cannot do this. You have to make two separate constructors. One for when the user didn't give one of these. So just when it's blank, we'll say, okay, yes, x is 0. That's what the count starts out as. Otherwise, if the user did give us something, it wasn't it was some certain value, and we got it, we'll set our x to be that starting value. Okay, so that's what you have to do in Java. You have to have two separate constructors if you want to have like a default kind of one, and then another one. Technically, you could get away with not writing this because some things are default initialized to 0, numbers are, but this is much better practice. Okay, let's make a Git Count method now, which will return back the count. And so our count is stored in this member variable called x. I guess I could have called it count, but I didn't. And so this is going to be a getter, right? So in C++, we would have said something like int get count const return x, yeah? So in Java, we got to be like, well, it's public. We're getting the count back. Const does not exist in Java, sadly. Unfortunately. Did I write that anywhere else? No, I don't think I did. So const does not exist in Java, sadly. So you cannot like discover or enforce at the compiler level that get count is not going to change x, change any of our member variables. There are ways to get around this, but they're a bit complicated and it's not as fun. So you're just kind of stuck making sure that you're not going to mess with anything. You gotta kind of trust yourself a bit more than C++. Okay, let's make an inc method now. Again, this is a public method because the user can use this thing and have fun with it. So public inc public void, sorry, does nothing, returns back nothing, but it does the process of adding one to that thing. Alright, so void inc takes no parameters, and all it does is x++. That exists in Java. Okay, that's inc, and again, I would like to make a reset method, but I'd like to give like a default value, and so I cannot do the thing that's like, okay, public void reset new value equals 0. No, I gotta make two separate ones of these. One with a parameter, one without. This one will reset it x to the new value, and the other one will just be like, okay, you didn't give a value, so it must have been 0. Okay, so that is reset. You gotta have two of them again because there are no default parameters. Okay, let's also do the thing where we could make a counter and be like C1 plus C2, like that. We want to add them together and get back a new counter C3. It's all going to be a little bit different in Java, but let's talk about that. One thing that is very unfortunate about Java, and I'll actually say this on the next slide too, but there's no such thing as operators. You can't overload operators. So you have to make .add instead of .operator plus. Okay? You got to use words. It's unfortunate. So if I want to add a counter to another counter, well, I'll make a method. It's like, okay, public counter returns back a counter, add, and then it takes a counter. Just call it other, I guess. And it returns a counter. And again, we want this to be const. We would also like to do something like const counter other. You also can't do that in Java. So you have to trust yourself a bit more. Or use fancier methods for getting those things. Okay, so that's what we got. Counter add, counter other. Can't have const anywhere because that doesn't exist. So we're going to make a new counter and give that back. Okay? So make a new counter to give back. So we'll just do it all in one fell swoop. We'll say counter ret, like the counter that I'm going to return. We can't say semicolon here. Everything has to be made on the heap, remember. So counter ret equals new counter. And what should its count become in the very beginning? It should be, well, our current count plus others count. Oops, other.x. And then we can say return ret. And notice something very special. There are no pointers anywhere, just like we were talking about when I made those arrays. Got to use new and delete for everything. Instead of leaving back pointers when you say new, because you're saying that all the time in Java, you just get back a reference. In Java, it's called a reference. It's all slightly different than C++'s version of a reference. It's like a pointer and a reference together, in a sense. So that is how that works. And so you can just do the dot. It kind of like dereferences it for you so that you can use the dot. It makes it a bit easier, I think. So you can immediately say like, okay, reset ret.x equals, I don't know, 42. You can totally say that even though ret is something that new gave you back. It's not really a pointer, it's a reference, okay? It's Java's version of this thing called a reference. Slightly different than to C++'s version. Okay, so that's our counter class. So every counter has a member variable called x inside of it. So if I say counter c, can't make it on the stack, I gotta say counter c equals new counter with like 42 or something. So that will make me my c, and It really lives on the heap. It's really like a pointer to this counter object with an X and 42, but in Java we just think of it as one big thing. It's immediately dereferenced for you. So you just think of C as that thing. It has its X set to 42 now, and I can say like C.inc as usual. No dereference is necessary. Now it's 43. Okay, so that's what we can do. And so let's test our stuff out by writing a main function. And I can write a main function that has nothing to do with this class, remember, because it's static. But I can write it in the same file, in the same little class, the counter class. But it's not a method, it's just a function. Okay, so it's always public static void main string args. String is capital. The fact that it's an array of things, you got to put that next to the type rather than after the name of the variable. All little subtle differences, but it's all still familiar, I hope. Okay, and there's no like return 0. This is a void function finally. Makes a bit more sense, I think. So let's test our stuff out. We got to make a counter. Counter C equals new counter. Test the default constructor and be like, okay, let's print c.get count. Whee. So that'll work. All right. Was it supposed to get count? Yeah, I think so. Okay. So we just made a blank counter. It has 0 inside of it. Let's print out its count. All that stuff. So I'm going to compile and run now. So Java C counter.java, and then Java counter. Even though the name of the thing is counter.class, you don't say the .class when you run it. So Java counter. And bam, we get 0. Nice. Let's try and inc this a bit. C.inc 3 times. Oops. Recompile. Rerun. 3. Cool. All right. Let's make another counter. 42. Let's make sure that worked. Let's test out C2's get count. Okay. Sweet. Now let's add them together. Let's test our add function. So sadly we can't say C plus C2 anymore. We gotta say counter C3 equals C dot add C2. So we don't have any operator plus. Okay, so let's test that this did the right thing. We'll print out its little count. Let's see here. Then we can do C3, sorry. That's what I wanted to change there. And hey, we get 45. And now let's test our reset, C3.reset. Both to 0 and C3.reset to some other number. So we should see 0 and 42 at the very end now. And I think that's everything. All right, I'm pretty happy with that. So that is the counter class. And this main function is just a function. It's along for the ride because it's static. It's not part of any object. So we can't say like c.main. That doesn't make sense. It's just, you can have a main function inside of this class. It's a bit odd. Another thing that you might have noticed is you don't have to declare anything. There's no function/method declarations in Java. You just start implementing everything. So private int x. But all these things, like I don't say, okay, the constructor exists, I will define it later. No, you just give the definition next to the name of it. And also the order doesn't matter. If that bugged you in C++, it's a lot better in Java. Order of things don't matter. Java will find that function that you wanted. So for example, if like for some reason inc called get count, you don't have to put get count above inc. It could be down here. That is very different than how things were in C++. So you can just put things in any order, Java will find them, which is fun. So that's counter in a nutshell. Now let's do something a bit exciting after we talk about the differences between all these things. So significant differences between Java and C++. Thank you, Bill, for this slide. So the first thing, we've talked about it a little bit already. Java is an intermediate language. It's not a compiled language. So you do use Java-C, which is called the Java compiler, but what you get back are those class files. Those are not like immediately runnable on your computer. You have to run them through the Java virtual machine, which I should have made another box for that, really. So it's a bit different, but there are some trade-offs. And instead of const, if you want just constant variables, those exist. Instead of const, you say public static final. That makes a constant that you could use somewhere else, like pi. Instead of char, there is byte, but every character is just a byte, so that kind of makes sense. No pointers, only references, as we talked about. You can say new and just start using, you can say the dot instead of an arrow or anything, which is interesting. No operator overloading, we've learned about this. Sadly, we cannot do that. And then something I'm going to show you on the next example is if you want to include library stuff, you don't say #include, you say import. Okay, so that's a small difference. So you import packages, or what they're called. And if you happen to read ahead the inheritance part of the textbook, which is not required for this class, you'll know a bit about this concept called inheritance. I hinted at it a little bit. You'll learn about it in detail in CSCI 41. But there's a parent class for every class, and so it's all everybody extends from object. If that makes no sense to you, don't worry. Some other things is Java is really nice to their programmers. These automatic documentation pages are generated from comments that you leave, and so those things that we were looking at last time, these are all automatically made and part of the Java documentation. So you can make your own fancy library and just get this documentation style for free. Make websites. So that's nice. And you can also give nice compiler hints as well. This is something that I don't have time to show you, but feel free to come to office hours if this interests you, and I will totally, I can talk to you all day about it. And then finally, this thing that we've talked about a little bit, we have garbage collection in Java. So it goes and it cleans things up for you. So delete is called for you automatically. There is no delete, only new in the language. It just notices when you're done with something and it cleans up it for you, which is lovely, especially because you have to make everything on the heap nowadays in Java. So that's the reason we can say, okay, new, okay, new. And then the add method as well, it says, okay, new. We never said delete anywhere. There are no leaks though, because once the main function ends, or wherever these things were finally finished with, they weren't being used anymore, maybe another function or something, Java notices, like, okay, C3, nobody is looking at that anymore. Nobody has any way of getting to it, so I'm going to delete it for the programmer. So that's a nice thing that you don't have to worry about anymore, and that's why we're making sure that you learn C++ so that you're forced to clean up your own memory. So you don't get the easy way out for that. Okay, so something that I'm very excited to teach you now is graphical user interfaces, or GUIs. Now, we're going to make a GUI for our counter class. Okay, so GUI stands for Graphical User Interface, and Java's standard library is kind of amazing. So maybe I should have put that here. Standard library is awesome. It's ridiculous. So not only does it have all the stuff that C++ has, like all the fun containers, it has their own version of vectors and things like that, of course, but it also has graphical things pre-implemented for you. So Java, the standard library, is one of the reasons why Java is very popular. It just has a really nice standard library where things are ready for you. So we're going to make a GUI for our counter class, and we're going to use, it's called swing. Swing is the type of objects we'll use. So I have pulled up the javax.swing package, so you can see what's all inside, and that's this link right here. And you can like see little examples, read all the documentation. We're going to make a bunch of these little things, and yeah, I guess let me go to the example and we'll talk about all this stuff. Okay, are you ready? So over here I have made a file called countergui.java, and of course there's a public class called countergui inside of that. And finally I'm including library stuff. Oops. There's our swing library. This one is useful for when we click on buttons. So let me just show you this running so I can tell you where we're going with this. But it's using counter, and you actually don't have to import counter or anything. Everything in the same directory is automatically imported for you, so we don't have to import counter or anything. We can just start using the thing. Okay, so let me show you this running. Don't look at the code just yet. Here's the cool thing that we're going to implement. So counter's already compiled. I'll compile it again for fun. But now let's compile countergui.java, and then let's run that. So for once, we're making not a terminal program, which I'm really excited about. Sorry I had to wait so long to do that. But here is the window we're going to make. And it has a counter at the back end. It's got a text field and 2 buttons that work with our counter stuff. So I can say, I can click this button physically on my computer, and bam, I get a 1 here. This is really nice. This is very satisfying. Oops, I can make it giant if I want to, resize it, but the default size is really nice. Hit increment, hit reset to set it back to 0, and then I can increment it some more. So that's what we're implementing in this file. And let me show you how we do it. So do come to office hours if you're interested in this stuff. There's obviously so much more that I could talk about, and I might not have enough time to like get you where you want to go with all of this. Like maybe this is something you'd like to do on the side for yourself, make your own little windowed programs. But let me give you at least a start. So everything we're going to do is going to be in main for the most part. I've made made one helper function, and then we'll also keep track of the counter that we're going to use as our underlying data for this window. So the window has all those buttons, of course. Boop. The window has the text field and the 2 buttons that you can click on. And everything, like the data associated with all those buttons and things, is our counter object. There will be a counter object sitting around. It's like x42. So C will be the data for this window. So like the count will like be reflected in this little text field. And when we say, when we click increment or reset, those call c.inc, c.reset. So we can use the class that we made, the counter class, as like a wrapper, like the data portion of this window. And that's a really nice programming pattern. You've got one class that worries about like the data, and then another class that worries about how it's presented. Okay? All right, so at the very beginning of our program, we're going to set up a brand new counter, and so we want the count to start at 0, of course. And then we're going to start doing the swing-specific stuff. I'm going to try and explain it to you as best as I can. So let me comment out a whole lot. Whee! Down here we go. How about that? Okay, so just a few lines now that I'll talk about. So we make our counter object. We're not going to do anything with it just yet. The first thing that we're going to make is a window for our program. And a Jframe in the swing library makes a window. Every library is different, but this one, they call it Jframe. Everything starts with a J. So that's a window, and you can see all this cool stuff that you can do with your windows. add stuff to them, of course. One thing that we will do is give it a name. So when it pops up, like the title of the window will be counter GUI. And then also we will set its default close operation, because for some reason when you click the X, it doesn't actually close the program unless you do this. Don't know why. So we're going to call that method on our frame. So we can search for that. We can see, oh, what is that? Set default close operation. Whee. There it is. And we want to exit on close. There are some things that like only hide the thing or don't do anything at all. Not sure what the default is. Dun dun dun. But we want it to exit on close, which is just a fancy constant that is apparently an integer. That's just how the library is implemented. You don't have to worry about this. But that's what we did. We make a window, and then we display the window. One thing that we do is, I don't think that this is going to, we'll see if this compiles, or actually works properly. We then adjust the window itself to hold its content. So we resize it, like, to hold all its stuff. And right now it holds nothing, so it might be empty and tiny. We'll see if that works. And then we're going to say frame.setVisibleTrue, which displays the actual window. So if I go to that, set visible, boop. Just be like, oh, shows or hides the window. Okay. This is a lot of things. And you can see that Java is very, very wordy. Can't have operators, so everybody has really long names. Set focus traversal policy provider. Yeah, of course. That's exactly what I would have named it too. So Java is known for being very wordy, just so that you know. Okay, let's see what this does. Hopefully it works a little bit. I have a window and it's somewhere. Is it large or small? I think it might be tiny. Okay, I don't see it. So darn. Yeah, I think it has 0 width, 0 height right now. So what if I get rid of this little pack thing? Maybe that might fix it. And make it just super tiny but still visible. I don't see anything, sadly. Darn. Oh, there it is. There it is. There's the window. There it is. We found it. Okay. Going back to it now. I can resize it, but it was so tiny because there was nothing in it. And so it's just empty. But here's the window. We gave it counter GUI as its name, and we gave it its stuff that goes inside of it, but we gave it nothing. All right, so let's give it stuff, and exit closes it. Hey. All right. Cool. So the first thing that we'll add is it's called a panel, and a panel holds components, we say. So the panel is the stuff inside of the window that we'll use to arrange things on. So inside of the window, there is a panel, and you can think of this as like the panel, and then this is the frame. Okay, that's the idea. So this is the panel, this is the frame. These are just the way that these implementers of the library decided to do it. That's the idea. So we make a panel to hold components, and then we'll start making some components to put in the panel. Okay, so the first thing that we're going to make is a text field. So to hold that number, that's called a JText field. And you can look that up and see what it does, all the cool fancy stuff. JText field. You also have many different options, and I encourage you to try them all. JText field does stuff, and you can see all about it if you'd like. But let's see here. The thing that we're going to eventually care about is setting its text. Dun dun dun. Which I do not see at the moment. So like set text is defined here because it is a text component. So we're going to call that to set the actual text eventually. Okay, so enough with the documentation. It's kind of weird to think about. So the constructor for a text field, one of them, it asks you how wide you want the text field to be, and we want it 3 characters wide. Why not? And then we want it to not be editable, so that the user can't type things in it. We want to only type things in it from the counter itself. So we're not going to let the user change the contents. And then we're going to set the text initially to be whatever the count of the counter is, which will be 0. And then I'll also make this font size huge because the default's kind of tiny. So I'll make the font size 32, and that is a helper function that I made down here. That's the one helper function I made. It takes a component and a new size for the font and just like does the library version of setting the font. Not too fancy. Okay, so that is the text field. Let's see what happens when we add that, but nothing else. All right, so we have our window. We have to add the frame to the window. That's what that line does. Then we also have to add the text field to the window. So I guess I can just get rid of all the comments probably. No, I don't add those buttons just yet. So how about I add the ending comment there and then make sure that these buttons don't get used just yet. Okay, so I just added the one text field to the panel, add the panel to the window, change the window size to be the size of what's inside of it, make it visible. Okay, it's a lot of little processes, but they all should make sense. Hey, and so we have a tiny window that holds the size of this one text field. Hey, and it holds 0. Very nice. Okay, let's add the 2 buttons now, and then we'll talk about how to make them do stuff when we click on them. So here are our buttons. I've called them Ink and Reset, and they are J buttons. And I've changed their font sizes to be huge. And then we need things to happen when we click them. And let me comment those things out. That was from 41, never mind. Okay, so now I have buttons that don't do anything just yet, and I've added them and resized the window to hold that stuff. Let's open it now. Okay, we have a working thing. It holds 0. We can't change that. I can't type. And I can press increment, I can press reset, but they are not hooked up to do anything at the moment. So that's the last piece of the puzzle. These things, these buttons, when I click them, they need to call methods on my counter and then also reflect the changes in the text field. Okay, so we have to change the text field a bit. We have to operate on C a bit as well. Okay, so here's how you do it. It's just the library-specific way. Don't worry too much about any of this. You can just copy my stuff if you want to do your own thing. You say add action listener, because a click is apparently to Java, to the Swing library. It's called an action, okay? And then I'm going to make an anonymous class, is what it's called. So a small little class that has the action listener thing that has the property that it listens to the action, and it knows when it gets performed, and then it knows what to do when that action clicking gets performed. So it's a lot of words. Really, all you need to care about is the body here. Okay? So we add this action listener to do these 2 things whenever the ink button is clicked. The first thing that we do is call the ink method on the counter itself to manipulate the data there. But that is just a counter object. It has nothing to do with what's displayed on our screen. So we need to change the text field as well, the tf.setText, to be whatever the count is. Okay? And then because we need to set text, I didn't explain this yet, we have to change the integer to a string, because the set text takes a string. Okay? That's how you do it in Java. Convert an int to a string. That's one of the ways. So now we have an action that actually increments things. Increment C and also reflect the changes of C in the text field. Then we'll do the same for reset. Call reset, reflect the changes in the text field to C. Okay. This is really exciting. And so now I've told you everything you need to know to go and make your own version of this with fancier things. So that is just the tip of the iceberg for Swing, for Java. That's all I really have time for, though, sadly. You can make toolbars, little tables, sliders, scroll bars, radio buttons, pop-up menus. There's so many things, and this is fun to play with. I'll say that. So that is where I want to leave you with Java, sadly. Just come to office hours if you want to know more. I'd be happy to teach you, but that is as much time as I have for that. Let's talk a little bit now about Python, which is another language. It's a bit different, and here's a famous XKCD comic about Python. Oops. Again, you can go to this learnxandYminutes.com to learn a bit more about Python, a quick little intro that I encourage you to read if you're interested. Let's start now with Hello World. So in Python, this is actually going to be one line of code because Python does not require a main function. It just starts writing, you just start writing code and it starts executing those lines of code, which is nice. So let's do Hello World. All right. I'll make a new file called hello.py. And here's the one thing that I'm going to put in it. Print, call the print function with hello world. Bam. That's my program. And Vim is going to complain because it doesn't like when programs are written outside of functions, but who cares? This is valid Python. And now to run it, you say Python 3, okay? You say Python 3 file name. Yeah. .py is the usual extension for Python programs. To run your program, just immediately run it. No compilation necessary. We'll talk about that in a second. So Python 3, because Python 2 is horribly outdated. All the cool kids use Python 3 nowadays. Python 3, hello.py. And it prints hello world. Hey, so this is beautiful. This is why a lot of schools teach in their intro programming classes Python. It was very quick to do something. It makes a bit more sense, I think. So that's Python's hello world. Some weird things. Comments now, not like Java, not like C++. Single line comments are number signs, so hash signs, just like makefiles. This is a single line comment, and then you can use triple quotes to make multi-line comments. This is a multi-line comment. That's the idea. That's hello world. And then also, strings in Python are a bit odd. You can also have single quotes. There's no difference. There's no like char type. So this is just print hello world twice. Those are two equally valid ways of printing, of making a string to print. That's just the string part. So this is actually the more idiomatic way in Python to use single quote strings. But I'll probably default to double quotes because that's what every other language likes. Okay, so that's hello world in a nutshell. Now let's talk a bit about all the differences between Python and C++ now. So, and Java, I guess. Python is what's called an interpreted language, so there's no compilation process. You go immediately from the file. Oops. You go immediately from the file, which has code in it, has Python high-level source code, not ones and zeros. You give that to Python, and it runs it. Like, gives you output. So it's like looking at line by line, each line, just going and running them. It's like, okay, you said print, so I'm going to get ready to print whatever the contents of this is. I'm going to evaluate that to some kind of string or printable thing, and then I'll go and print it to the screen for you. So that's what's called interpretation. It's like you're talking to Python, and it's like translating it on the fly to computer code. And that actually makes it very slow. So because it's doing this on the fly, it can't like optimize things. Compiled code is a bit faster, actually significantly faster. So Python is much slower for like very computation-heavy tasks you should not be doing in Python for this reason. Another thing about Python is that it uses what's known as dynamic typing. So if you want to write a there are no types. Python just figures out the types for you. Or if you use the wrong ones, it'll complain at runtime. It'll just let anything run. because there's no compilation, there's no checking. So let's see, I can just immediately say that x is 42, and then I can print x, and then I can also say that x is now hi mom. Oh man, and I can print x again. So there's no type associated with x, which is interesting. And this is the source of many errors in programming, but Python is okay with that. So I can immediately print 42 and then put inside of x, hi mom. Who would have thought? So that's what dynamic typing gives you. And you can also make functions. Functions in Python look like this. Let's see. Yeah, that's where I want to be. So to make a function that, I don't know, prints a number plus 1. So like the function will be called print plus 1 42, and it'll print like 43 or something. So this is that's that function. So the way that you do it in Python is you say def, and then the name of the function, print plus 1, and then we'll say the name of the parameter. Again, no types, no type, no return type. Then you put a colon, and then you tab over and give the body. There are no braces. All right, so then we'll say print x plus 1. So that is Python in a nutshell, and it prints 43. And white space now matters in Python. Not like Java, not like C++. In order to define a function, you have to tab over. You need to use indentation. Oh, sorry. No indentation, just what was I saying here? No braces, just white space, sorry. And that includes indentation, my bad. Instead of arrays, you have things called lists, and Python also has, and you might have seen me use this before, what's known as a read, evaluate, print loop, or REPL for short. Read, evaluate, print, just keeps on doing those things. So Python, you can just say 2, and it'll run Python code, a single line of Python code. And so you can be like, print, hi, on the REPL, like you're writing the program, x equals 42, print 2 times x. This is very helpful for quick math, if you want to do that. So you can just start, write Python without any program associated with it, and just start writing Python code, and it will read what you type, evaluate it, and print it out. That's really nice. So Python has cool stuff like powers of things, 2 to the 8, apparently that. It has unbounded numbers, so you can be like 2 to the 100. This is much bigger than an int in C++ would ever be able to store, so Python is just allowed to do this. Bam. Numbers as big as you want. Yeah, the libraries are super awesome in Python too. Yeah, I think that's where I want to leave you there. Instead of arrays, people use lists, and so lists are built into the language. Like here's L equals 1, 2, 3, and then I can loop through that with a for loop, for x in L, print x. I'll print 1, 2, 3. Cool. Yeah, and so again, loops, like you gotta colon and indent, colon and indent. That's how you know when you're in the body. Instead of else if, there's elif, which is a big change. I just made one shorter thing. And then, I'll show you in the next slide, methods, you have to secretly declare that this parameter. And in Python, this is called self. So that's why you did that lab. And the libraries are super awesome also in Python. Java and Python have extra good libraries. So before I let you go, let's do a counter class, and that's about it. So let's make a counter class now. Again, indentation is key. Then we'll talk about these other things. So counter.py, so class counter. What do you know? Tab indent. The constructor is called init. And so here it is, def init. And you can have default values and be like x count equals 0. That's a default. Then we can say count equals 0, but we have to like specify things now. Member variables are declared inside of constructors. Every method takes an implicit, well, but it's explicitly said, let's just call it explicit, self parameter first. And that gives you a pointer, let's say, to the object itself. So now we can say self.count equals count. So this makes the member variable right here. You don't do it outside. It's a bit odd. So that's our constructor. Then we can have an inc method, def inc, implicitly takes self, but you have to be explicit about it. So then you'll say self.count plus equals 1. There's no plus plus in Python. Then you can be like git count, def git count, self again. Then you can say return self.count. So Python is also garbage collected. And there is no new in Python. You just call the constructor as if it was the name of the class itself. Okay? So method calls, when you call the methods, they automatically pass along self, which is interesting. So here's how I make a counter. C equals counter. Yeah? I'm going to be like C2 equals counter with 42. I can print out their counts. Print c.getCount. Notice that I don't need to say self anywhere. At the use time, at the time of use, for each method, self gets passed for you. It knows. It's like, oh, okay, self is C. Self is C. Self is C2. It just does it for you, but you have to explicitly declare that first parameter. It's a bit odd. Feel free to complain about this with me in office hours. This is something that I also don't quite like, but it's just another way of doing things. So we should get 0 and 42. Cool. Then we can call inc. Let's call it on this one. C.inc a few times. So now we should get 3 and 42. Cool. So that's our counter class. So it's a bit different. And that's all I wanted to show you about Python. One really cool library is called Turtle, and let me use the last couple minutes to show you some cool stuff about that. So let's pretend that this is what the library is all about. Pretend that there is a turtle, and somehow, this is my best turtle drawing, his tail got dipped in ink. I'm not naming names, but this happened, and so this library allows you to move this turtle around the screen and draw things. He will respond to your every command. Okay? That is a really nice library that I like to use in my CSCI 1 class to teach students programming. So that is Turtle. Let me just show you a few things that you can make in Turtle, and then you can explore them on your own if you'd like. So here's one thing that you can make. Here's the library documentation. So you can make really cool things with your turtle. The turtle is an arrow in this case, but you can make the turtle look like a turtle too. So you can just move him around, like go forward, go left, and you can draw stuff. It's really, really cool. And you can change the colors and all that. So let me show you 2 examples of Turtle, and then I'll let you go. So the first one is the Mandelbrot Fractal, if you are interested in that. This is how you use the Turtle library, again, import it, to do cool stuff. So this is nice and commented, so hopefully it makes sense. Who knows what my errors are, but that's okay. So let me show you this, and hopefully you can walk through it yourself, using the Wikipedia page maybe. But this is going to draw the Mandelbrot fractal using turtles. So Python 3, Mandelbrot. So that's one cool example. And so you got a turtle, he's drawing this fractal, which is very complicated, but he's just working his way from left to right. And you can draw fancier things like in lines, but this is like 1 pixel at a time for this one. So that is the cool Mandelbrot fractal plus a turtle. That's one example. And then my other one is, you know that Joy Division album that all the hipsters have t-shirts of? Well, that is something we can draw with turtles as well. So actually, the data on that album cover is a signal coming from a celestial object, and we can just reuse that data and draw with turtles that album cover / popular t-shirt. So this is a bit more complicated, but feel free to walk through it yourself. I'd be happy to go through it with you in office hours or on Piazza. But here is the turtle drawing the Joy Division album cover. And you can see him working away. Very, very fun. And so at the end of this, you can be the ultimate hipster and have this album cover not only in cool, like, pixelated almost form, but there will also be a turtle at the very right side. So that is an improvement in my opinion. All right, so that is Python, that is Java, that is all the time that I have to teach you languages other than C++. The final week of classes will just be review. Hopefully you got something out of this. It's not too bad. All these other languages, they look kind of the same. You can do similar things. It's just a slightly different syntax, and you will get used to it if you try it. That is all that I have for you. If you want to do any exercises, the best ones are to convert some of your labs to use Java and or Python. That's a great way to learn these languages. Like look up the little, go through the tutorial, and then change over one of your labs. Super, super useful, I would say. So that is Beyond C++. That is the one lecture for this week, and that is all I have for you. So have a good Thanksgiving, and I will see you in the next lecture.